good day. So, in this video, we will be talking about power series and integration. Okay. So, in the past, um, you have learned about um, different methods in solving um, differential equations and then integration of elementary functions. So in this case, we will be talking about power series. Okay, so there were actually some problems in which seems to be non-elementary, such as this problem. Okay, so this problem involves the division of cosine of x over x. Okay, so dy over dx is equal to cosine of x over x. Okay, but somehow though it looks like a non-elementary function in which we could not integrate in order to solve this differential equation, but somehow we can use its corresponding power series in order to solve it. Okay? So this is not only true for cosine x, so it can also have other functions that has its corresponding power series, such as the some trigonometric functions, for natural logarithm functions, etc. Okay, so let us have this example. Okay, so let us try solving this one. Okay, so we know in order to solve this, we need to know what is the power series or the expansion of cosine x. So cosine x is equivalent to 1 minus x squared over 2 factorial plus x to the power of 4 over 4 factorial minus x to the 6 over 6 factorial plus etc. series. So in power series, cosine x, so I have already written here, is equivalent to 1 plus the infinite sum of negative 1 to the n multiplied by x to the 2n over the 2n factorial. Okay, so the n here will count from 1 up to infinity. So this is its equivalent power series of cosine of x. So how to solve this one? Okay, so one thing we could do in order to solve this problem, okay, so is to divide all of these things. Okay, so we know that okay, so we replace, okay, everything by its corresponding power series. So cosine x is equivalent to this, so we will replace. So 1 plus infinite sum of n is equal to 1. Okay, n is to 1 and up till infinity, negative 1, n, x to the power of 2n over 2n factorial. Okay, then over x. So therefore, we can say that dy over dx is equivalent to 1 over x plus the infinite sum, n is equal to 1 up to infinity, negative 1, n, since this we divide it by x, so therefore this 2n will be diminished by 1. 2n minus 1 over 2n factorial. Okay, so therefore, we could already integrate. So we integrate that one, and then we integrate everything by this one. Okay. Okay, so this is already integrable. Okay, so we multiplied everything by dx. So therefore, y is equivalent to, okay, so this is, we integrate this. The integral of 1 over x is ln. Okay, is a ln of x. Okay, absolute value. Plus, since the infinite sum, okay, so we take it as 1 unit. Okay, So therefore, it will become n is equal to 1, infinity. So it will become negative 1 to the n over x to n minus 1. So we add 1 here. So it will become 2n over 2n factorial over this power, 2n. Okay? You cannot multiply this one because it is under factorial. Okay? So it is in factorial form. Okay? So D plus C. So this will be your answer. Okay? So take note, okay, how we do it. Okay? So we use, so therefore we can use power series in order to solve some of the non-elementary functions such as this differential equation. Okay, so the other way, okay, so the other power series, okay, the other terms that could be represented as power series are the following. Okay, so maybe I will erase this one. Okay, so since this is a video, you can always replay or rewind the portion of this video that you want to revisit. Okay, so I will just list. So other than cosine x, so there are other terms that is has its own power series. Okay, or expansion. So to add, sine x is also an expansion. Okay, okay, so we will rewrite it, this one. So cosine x is equivalent to 1 minus x squared over 2 plus x fourth over 4 factorial minus x6 over 6 factorial. Okay, so which is equivalent to 1 plus infinite sum n equals to 0 to infinity negative 1 to the n. Okay, x to the power of 2n over 2n factorial. Well, the sine x is equivalent to 1, okay, no, x, okay, this is an infinite sum, I mean, yeah, and then x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7 over 7 factorial, and so on. So that is sine x. So when we convert it, okay, into power series form, it will be equal to infinite sum n to the 0 to infinity negative 1 to the n. Okay, so x to the power of 2n plus 1 over 2n plus 1 factorial. So this is your sine of x. This is equivalent of your sine of x. So you can use that, okay? So there are a lot of problems in non-elementary problems in which if you in which if you convert, okay, so if you just convert sine of x into power series, so you can solve the problem. For example, dy over dx is equal to sine x over x squared. Okay, so that could be a problem. Okay, or else dy over dx is equal to sine of x squared. So just as many as non-elementary functions, you can solve this one. Okay, so just replace. Okay, instead of x squared, okay, since sine x squared, so you can replace x as x squared. Okay, so we will not solve that one. Okay, so just me. Okay, so you just combine it with your knowledge in algebra, so you can already apply power series in order to solve integration problems or differential equation problems. And then others will be hyperbolic cosine. Others will be hyperbolic functions. For example, hyperbolic cosine of x, it is equivalent to 1 plus x squared over 2 factorial plus x fourth over 4 factorial plus x over 6 factorial plus, okay, infinity. So it's equivalent actually to 1 plus n is equal to 0, infinity. So there is no negative 1 to the n. It will become x to the power of 2n over 2n factorial. Same for hyperbolic sine of x. So x minus x cubed over 3 plus x over 5, okay? It will be plus. Everything will be positive. So plus x to the 7 over 7 factorial plus infinity. So hyperbolic sine of x is equivalent to n to the 0 infinity. Okay, negative, there's no negative anymore, so it will become x to the power of 2n plus 1 over 2n plus 1 factorial. So that is some examples of power series. Okay. So other terms of power series, we also have for, okay, natural logarithm. Okay, so let's begin. Okay, so maybe let's have this. So we also have e to the power of x. Okay, natural logarithm. This is the e is the natural logarithm base. So e to the power of x will be 1 plus x squared over 2. Okay, plus x cubed over 3 factorial plus x4 to the 4th factorial plus and so on. Okay, in terms of power series, it is equivalent to the infinite sum from n is equal to 0 up to infinity, in which x to the n to the power of n factorial. So this is in the form of power series also. Okay, so another one is ln of x. Okay, so ln of x. Okay, so I would like to add, so ln of x will be, ln is equivalent to x minus 1 minus x minus 1 to the power of 3 over 3 plus x minus 1 to the power of 5 over 5, okay, and so on. So it is equivalent actually to the infinite series n to the 0 to infinity, where your, okay, x minus 1 to the power of 2n plus 1 over okay, over 2n plus 1. Okay, of course, we will multiply it by negative 1 to the power of n. So that's its equivalent. This is the equivalent power series of ln of x. Okay, so I hope you learned something. Okay, so just if there is an elementary non-elementary functions that involve ln x, for example, ln over x, so you just replace in this power series. And before I forget, this x for ln of x, so this is actually equivalent when an x is between 1 and 2 only. Okay, so this is for ln of x between 1 and 2 only. So for this case, okay, so if you're going to integrate and then it is within the limits is within 1 and 2, or inside of that values are the limits. Okay, so therefore you can apply this formula. Okay, so these are the power series: cosine, trigonometric functions, hyperbolic functions, and then the logarithmic and exponential functions such as this. Okay,